So the topic we need today, so everything in Unit 1 is about solving equations. Okay, so we've spent a lot of time on factoring which allows us to solve equations. We need to branch into a couple of kinds of equations that have a couple of curveballs that you haven't seen so far in the class and how we solve those. So what we'll talk about today are rational equalities. In mathematics, what is the word rational usually? What does it mean? Okay, in terms of rational numbers, yes. But a rational expression is something that can be expressed in this form. Like 2 can be written as 2 over 1. 1 can be written as 1 over 1, 1/2, 1 over 2. Pi cannot be written as a fraction. So rational means it can be written as a fraction. So that's what it means for a rational number. But rational expressions are expressions with variables, which is all really algebra is full of. But I've got expressions with variables, but these expressions here, what are these that we haven't seen before? They occur in what? Starts with an F. These are all fractions. So these are all rational expressions that have fractions, okay? So how does that differ and what different strategies will we have to solve that? Now here's the biggest thing. There are two kind of restrictions we're going to have in this class when we start to solve equations. I don't know how many times I've tried to explain it, try to simplify it. We get to the final exam and people don't know what the restriction is. So I need you to really focus on this restriction. I think it's pretty straightforward. When I look at this, one strategy when you see something like this is you've got a fraction. Okay. What in terms of fraction, what number can we never divide by? 0. Okay. So this expression is perfect, it's good, it's fine, it causes me no problem until I'm dividing by 0. Okay. What would have to be 0 if that were to be dividing by 0? What expression would have to be 0? X, not 1, x plus 1, the whole bottom of this fraction. If x plus 1 is 0, that gives me 1 over 0. So that's the condition that I cannot have, okay? So in this particular problem, x plus 1 cannot be equal to 0. So if x plus 1 cannot be equal to 0, what can x not be equal to? -1, okay? So all you need to do is when you see something like this, whatever this bottom of the fraction is, you know that cannot be 0, okay? X plus 1 cannot be 0. If I subtract 1 from both sides, that tells me that x cannot be -1. Okay, that is we'll have several words for this. We can call this a restriction. We can call it an exclusion. You might see the word a domain, and we'll talk more about domain later, but a domain restriction. All of these mean the same thing. Restriction, exclusion, domain restriction. It tells me that, and I look at that expression, it is defined in every case except when x is -1, because when x is -1, this becomes -1 plus 1, that's 1 over 0, that's undefined. So we have to pay close attention in rational expressions to what those restrictions will be. Now, let's talk about how we're going to solve this. So we've got 1 over x plus 1 equal 2. Okay. Now, what is it that you don't like about solving this? What is it you don't like? When you look at it, it's a fraction. So our strategy is to get rid of the fraction. If it helps you, you can put parentheses here. What if I were to multiply both sides of this equation times x plus 1? Now, what is x plus 1 divided by x plus 1? They cancel or it's 1, so that is just 1, okay? The reason I multiply by x plus 1 because that makes this side of the equation a whole lot easier. 1 is equal to 2 x plus 1. Now, does that look like an easier problem to solve? Yeah, so to solve this problem, I get 1 equal 2x plus 2. And then what do? I subtract 2 from both sides. So I get negative 1 equals 2x. And then what do? I divide everything by 2. So I get x is equal to what? Negative 1/2. Now, you got to be in the habit of always checking what was the number x could not be equal to. Yeah, so I know that x cannot be negative 1. Does this answer violate that? No, I'm good, okay? So it's perfectly fine for x to be negative 1/2. If I had come up with the solution x equal negative 1, I would say that's not going to work, okay? So that's why up front, determine what the exclusion or what the restriction is. Go solve the problem, double check your answer to make sure it doesn't violate what you know to be the restriction. So in all of these problems, our strategy is going to be converted to a problem that does not have expressions. So again, what number can we never divide by? We can never divide by 0. So that means that when I look at a rational expression, the denominator can never be equal to 0. That's how I find my restriction for all of these. Now again, I kept saying that factoring was important. It keeps coming up. You need to know how to factor to solve these problems as well. So I've got another one here, x plus 3 over x squared minus 9 equal 2. Now what you really need you need to make sure that the denominator is factored completely. So let's do that. This is x plus 3 over, how do I factor x squared minus 9? Yeah, that's x minus 3, x plus 3 equal 2. Oh, I don't know why I did that. X minus 3, x plus 3 equal 2. Okay. Now, before I do anything, determine what the restrictions are. The restriction is the denominator can never be what? 0. So that means that x minus 3 cannot be what? X minus 3 can't be 0, and x plus 3 cannot be 0. Either one of those conditions would have me dividing by 0. So the first one tells me that x cannot be equal to what? This tells me x cannot be 3, and this tells me x cannot be what? Negative 3. So these are my exclusions. Before I do anything, figure out what the exclusions are. Now we go solve the problem. If either of these numbers pops up as the answer, it can't be the answer, okay? Because these are the only two numbers that make this undefined. Now let's work on this problem and simplify. This one has a nice simplification that's already there. What is x plus 3 divided by x plus 3? That's 1. So when I get to here, this is x plus 3 over x minus 3, x plus 3 equal 2. So x plus 3 over x plus 3 is 1. So this whole problem turns out to be 1 over x minus 3 equal 2. Now, what will I need to do to solve this problem? What can I multiply both sides by? By x minus 3. So I'm going to have x minus 3 times 1 over x minus 3 equal 2 times x minus 3. Why do I multiply by x minus 3? Because that makes this side a whole lot easier and there are no fractions. So all we're doing, we're multiplying everything in the equation by the denominator. So here I get 1 equal 2x minus 6. If I add 6 to both sides, I get 7 equals 2x. So what does x equal? Yeah, x equals 7 over 2. What can x not be equal to? 3 or negative 3. That's fine. That doesn't violate that condition. Okay, so that answer is good. If, pardon me? Yeah, if x equals 0, that'd be fine. What can't be equal to 0 is the denominator. So if x were 0, this would still be defined. Okay, so if you got x equals 0, that's fine as a solution, as long as it doesn't violate the exclusions. So the steps here are: make sure the denominator is factored. Use the denominator to find out what the exclusions are. You set every factor equal to 0, and that's going to be your exclusion. Then you multiply the whole equation by the denominator, solve whatever equation you get, and just make sure those answers don't violate your exclusion. Yes, Olivia? Right. You have to come up with the exclusion, what x cannot be equal to. No, if you could look at this, you could look at this and say, I'm going to run into a problem when x is 3 or negative 3. You could just write here, x cannot be 3 or negative 3. Right, you don't have to do this. I just typically do it because my process is, whatever you see here, this number cannot be 0. That number not being 0 means that x can't be this number. This is what I'm after. If you need this step or don't need this step, that's fine. It's only the denominator. It's okay for the top of a fraction to be 0. You know, so like if I had x plus 4 over x plus 5, okay, it's okay for x to be negative 4. That would be 0. But it's not okay for x to be negative 5. So it's no problem to have a 0 up here. The problem is when you have a 0 down here. So the only thing here is I know that x cannot be negative 5 for that one. It's okay for x to be negative 4. Okay. And I think here's where one gets a little bit harder. Okay. You want to make sure the denominator is factored completely. If I look at the denominator, everything's factored. I can't factor anything else. Okay. So that part, check on that part. Now let's determine what the restrictions are. What are the restrictions here? Yeah, x minus 3 can't be 0, and then what? X plus 4 cannot be 0. And then this translates to x cannot be 3, or x cannot be negative 4. So these are my two exclusions, or domain restrictions, okay? So that means I'm going to go solve this problem. If either of these numbers pops up, I know that it's not valid. Okay? Now, what I have to do is I have to multiply everything by the denominator, the common denominator. What am I going to have to multiply everything by here to get rid of the fractions? X minus 3 and x plus 4. So I got two things to multiply by here. So let's do that. So I'm going to have, and I'm going to try to use two different colors here so you can see it. So I'm going to have 2x over x minus 3 and then that's going to get multiplied by x minus 3, x plus 4. And then I've got plus x plus 1 over x plus 4. That gets multiplied by x minus 3, x plus 4. Okay, it's a lot of writing, but I'm just multiplying everything by the common denominator. Equal x minus 1 over x minus 3, and that gets multiplied by x minus 3, x plus 4. Now it looks pretty complicated, but it's about to get a little bit simpler. Yes? not sure. The trouble is with canceling. Sometimes people, I can't just. I have to multiply everything by x minus 3x plus 4. That's the denominator here. Okay, so it's going to get a lot simpler right now because x minus 3 over x minus 3, that's 1. X plus 4 over x plus 4, that's 1. X minus 3 over x minus 3, that's 1. Okay, so now what am I left with? I'm left with what? 2x times x plus 4 plus x plus 1 times what? X minus 3 equal x minus 1 times x plus 4. Now, I said it gets a whole lot easier. There are no fractions, but there's still work to do here, okay? Got a lot of x's, okay? What do you think I do next? Yeah, I've got to multiply all these things out to figure out what's going on. What is 2x times x? That's 2x squared. 2x times 4, that's 8x, okay? Now, I have to FOIL these. What is x times x? That's x squared. The outside terms. So when I look at the outside terms, that gives me what? Minus 3x. What happens when I multiply the inside terms? What do I get? Plus x. And the last terms give me minus 3. Equal. I multiply the first terms and I get x squared. Multiply the outside terms and I get 4x. Multiply the inside terms, minus x. Multiply the last terms and I get minus 4. Okay, it's still pretty ugly, okay? Let's work on the left side and see how things can get a little bit better. It looks like those two numbers are going to combine. What's 2x squared plus x squared? 3x squared. And then what is 8x minus 3x plus x? So 8x minus 3x is what? 5x. 5x plus x is 6x. And then I've got minus 3. So I combine the 2x squared and the x squared to get 3x squared. 8x minus 3x plus x is 6x minus 3 equal x squared plus 3x minus 4. This is looking better, okay? I don't like problems. I like to solve problems that are equal to what? 0. So let's get this thing equal to 0. So what I'm going to do, I'm going to subtract x squared from both sides. I'm going to subtract 3x. And I'm going to add 4. 4x minus x. When I multiply this together, x squared and then plus 4x minus x, so that's 3x. Pardon me? I got to move all of this over to the left, okay? So do you want to do that in 3 different steps, or? I'm like right this step. I'm going to subtract x squared from both sides. I'm going to subtract 3x from both sides, and I'm going to add 4 to both sides. The reason I do that, what is 3x squared minus x squared? That's 2x squared. What is 6x minus 3x? That is, what, 3x. What is negative 3 plus 4? That is 1. And what's on the right side of that equation? 0. Now this was a heck of a lot of work to get to this problem. But you guys are seniors. You're gonna. Now, how do I do? What do I do with this? Yeah. On this one, I need 2 numbers that multiply to give me 2, and add to give. I'll give you more space. What numbers multiply to 2 and add to 3? Yeah, 1 and 2. Okay. So I know now that this is what? 2x squared plus x plus 2x plus 1 equals 0. What method do I have for factoring that? Grouping. Okay. So I factor out an x, 2x plus 1 plus 2x plus 1 equals 0. Now, what's the final factorization here? X plus 1 times 2x plus 1 equals 0. So what does x equal? -1 or -1/2? Not all the problems. I can't make them all like this. This is as hard as it gets, okay? The ones we did earlier were not hard. The two I did before this didn't run into quadratics, okay? That made those a little bit easier. But you may have one that has a quadratic. It may not be this long, okay? The key to this, you got to stay organized, methodical, check your work as you go. Now, what were the exclusions? What can x not be? X cannot be 3 or -4. Neither of these violates that condition. Okay, so these answers are both good. Okay. If I were to come up with x equal -1 or was it 3, then you would just say 3 doesn't work. Mark through it. Okay. If you get down to here and the answer is what one of the exclusions are, it cannot be. Just mark through it at that point. Question? Yeah. If I came up with something like, if the answer were, x equal -1 and 3, I would just go back and mark, well, I know it can't be that. X is -1. That tells me that you went and you looked at the restriction and you saw that that was not a valid solution. Okay. So again, what were the steps here? Steps were the same. This one was just a little complicated. When I look at this, I look at the denominator. I've got an x minus 3 and an x plus 4. Neither of those things can be 0. To make the x minus 3 and the x plus 4, to make them both go away, I got to multiply this whole equation by x minus 3, x plus 4. That's what I did. I multiplied the whole equation by x minus 3, x plus 4. That gave me a different equation to solve that had no fractions. I had to multiply everything out. I had to combine like terms. I had to get it equal to 0. That led me down to a quadratic. This is why that factoring that we spent time on, you got to be, when you get to here, you got to know, oh, that's a quadratic. I know how to do those. Find two numbers with these properties. That led us to factoring by grouping. So all of this stuff sort of changed together in this unit. Okay, you guys work on this one, okay? Take a look at that one. 1 over x minus 1 equal 5. See if you can find the domain restrictions and solve this guy for x. Yeah, so that one's pretty easy. X cannot be 1. Okay. To solve for x, you've got 1 over x minus 1 equal 5. Multiply both sides by what? Yeah. When you multiply both sides by x minus 1, then you end up with what? 1 equal 5x minus 1. 1 equal 5x minus 5. Add 5 to both sides. 6 equal 5x, so x is equal to what? X is equal to 6/5. Does that violate the condition? No, x cannot be 1, so we're good, okay? That one we're good with. What are the questions about the next one? What's the restriction? Yeah. The denominator, if you'll get in the habit, if you've got a different color, just look at whatever denominators you see. So that's the only denominator I see. That cannot be 0. So x cannot be 0. So that's my restriction. Okay. Now I need to multiply everything by the denominator to get that to go away. So I've got x plus 3. Everything has to be multiplied by what? Not 0, by x. Okay. That has to get multiplied by x. And this needs to get multiplied by x. Okay? So, what is x divided by x? Come on, x divided by x. That's 1, okay? So, I've got x plus 3 times x equal -2. What will be my next step on that? Yeah, distribute on the left side. X times x is x squared. X times 3 is 3x. And then what will I do to solve that guy? I prefer it to be equal to what? 0. How do I make that happen? Just add 2 to both sides, okay? So you get x squared plus 3x plus 2 equals 0. That's a quadratic. I know, it's like problem inside a problem, but you guys can power through this. What's the strategy for solving this guy? I need what? Yeah, I need 2 numbers that multiply to 2 and add to 3. That's not that hard. What numbers are those? What, 1 and 2? Okay. So what do I do with the 1 and the 2? When you got something that starts with an x squared, and you know these numbers are the factoring numbers, what's my next step? X plus 1, x plus 2 equals 0. So what does x have to equal? -1, -2. Do either of those violate my restriction? What can x not be? 0. So these numbers are perfectly good. Okay. So here's the deal. The rationals, what's new is this restriction. The denominator of the rational can never equal 0. Okay. So that's one thing you got to look out for. Denominator can't be 0. You have to multiply the whole equation by the denominator, and sometimes that makes your equation get harder. And then you have to go back to, well, how do we solve equations? Well, it's factoring. So it's either a vicious cycle or a pyramid or something that things are building on. So I think we got one more, and then you should be able to be turned loose on this section. This denominator is factored. I don't have to worry about that. What's the restriction here? X cannot be equal to what? 2. Okay. That would have me dividing by 0. Now I got to multiply everything in that equation by what? By x minus 2. So I'm going to have x minus 2 times 5x over x minus 2. I recommend writing this step down so that there really aren't any careless mistakes. So everything gets multiplied by x minus 2. And the beauty of that is it looks complicated, but it gets a whole lot easier. That's 1, and this is 1. Okay. So now this problem boils down to what? 5x equals 7 x minus 2 plus 10. Now you should like this problem better because I don't see any x squareds. This is not a quadratic. This is a linear equation. Okay. How do I solve this? What do I do next? Yeah, so I got 5x equals 7x minus 14 plus 10. And this is just getting all your numbers together and getting all your x's together. Okay. I can subtract 7x What's 5x minus 7x? Yeah, so this is negative 2x equal negative 14 plus 10. What's negative 14 plus 10? Negative 4. So negative 2x equal negative 4. Therefore, x. Did I do something wrong? You want the 5 to the other side? That would work, okay. You'll get the same answer. If you did 5x over here, it'd be a negative 5x. So you get a positive. Either way, you're going to get the same answer. X is negative 4 over negative 2. What number is that? That number is 2. Does that violate my condition? So there is no solution. So all this work, and there is no solution. Okay, so you got to synopsis here. So this is what we did. In any rational expression, the denominator cannot be 0. That's how you find your restriction, your exclusion, your domain restriction. All of those mean the same thing. So you find that by setting the denominator equal to 0, and it has to be in factored form. So if you look at this one, the denominator, x squared minus 1, is x minus 1, x plus 1. So the restriction is x cannot be 1 or negative 1. So your steps, make sure the denominator is factored. You use that factored denominator to get your restrictions. Multiply the entire equation by the denominator, and then solve whatever equation you come up with, trying not to make careless mistakes, and then make sure your final answer doesn't violate the restriction. Okay? So what's going to happen when you multiply by the denominator, you're probably going to come up with a linear problem. That was what we just did here. I came up with a linear problem. Or you might come up with, in this case, a quadratic problem. Okay, those are sort of the two scenarios that are going to happen for you. And if it's quadratic, then you've got to pull back to that you know how to factor quadratics. Okay, so